So this morning I woke up to an interesting tweet from Brad Wood stating that in Lucee CFML, one of the big differences from Adobe ColdFusion is that values passed into a CFThread tag are actually passed by reference, not by value, which is what Adobe ColdFusion has done since the introduction of the CFThread tag. So to see this in action, what we can do is create a structure in the parent context with a key that's clearly defined in the local context. Then we can pass this value into this thread as an attribute and then attempt to mutate that structure from within the thread body. If this value is passed by copy or by value, then this mutation will not show up in the original structure. If this is passed by reference, however, meaning that the thread operates on the same copy or the same physical memory as that provided in the calling context, then we will see this mutation in the parent context. So we will execute this thread, wait for it to join, and then we will dump out the value. And then here I'm just checking to see if I'm on Lucee or ColdFusion so I can use the appropriate label. And then I just go ahead and invoke this. So if we run this in Adobe, and I'll refresh here, what you can see is that we see the local key, which again is the part of the structure defined in the function local scope. But what we don't see is the thread key, right? That is the property assigned to the struct within the CFThread body. And again, in Adobe ColdFusion, that's because that value is passed into the CFThread body by value, not by reference, meaning the thread gets its own local, isolated, deep copy to work with. Now, if we take this same method here and we run it in Lucee CFML 5.3, you can see that we have both the local key defined in the function local context and the thread key that's added as part of the CFThread body execution, right? We have local key and CF and thread key here, which means that this value, when it's passed into the CFThread body, is passed by reference, making this the same physical memory structure as this, which is why this mutation is showing up in the local values when we go and dump them out after the thread joins back into the page execution. So this is actually a fairly large breaking change from the Adobe ColdFusion mindset. And to be clear, Adobe did this for a very specific reason. Managing shared memory space in asynchronous control flow is a non-trivial problem. So they took the mindset that if we do deep copies of the values you pass into the thread, you never have to worry about shared memory access. Unfortunately, in practicality, this doesn't really help us because threads often have to communicate with the parent context, calling methods and iterating over other shared memory aspects through those methods. So you don't truly get the isolation that I think the intention here had provided. And now that Lucee has so many asynchronous control flows like the run async and the parallel iteration, it's really important for developers to understand what shared memory access entails in an asynchronous control flow. So I think it's better that the language defers to the developer in all cases instead of trying to solve this one particular case but then still leaving all the other asynchronous control flow shared memory problems up to the developer. I like the uniformity here and the potential performance benefits of not having to do the deep copy for all the values going into the CFThread. So huge thanks to Brad Wood for pointing that out. I had no idea. It doesn't seem to be documented even in the how does Lucee differ from Adobe overview. So excellent to know.